For problem 4, we have a very thin wire that is in the plane of the board. This wire consists of two circular segments, one radius A and another one radius B, and they are connected by these two segments that are along radii. There is a current I flowing in this wire. What we need to find the magnetic field created by this current at the origin. Okay? Which law will we use? In previous problems, we used Ampere's law. What we did, we simplified the left-hand side of the Ampere's law using symmetry. We took B out of integral, then we wrote circumference 2 pi r, and then we figure out what is current enclosed. That's how we solved the previous problem using the Ampere's law. Now we cannot be far away. This wire is not infinitely long wire. We cannot use this symmetry because we will have distortion of the lines of the magnetic field. So the easiest way to solve this problem is to use Biot-Savart's law that tells us that if we have infinitesimal piece of wire, let me draw a piece of wire here, infinitesimal piece of wire, and length of this piece is d little s, then the magnetic field created by this infinitesimal piece of wire at point of interest, that is distance r from this wire, is described by Biot-Savart's law, which is mu naught over 4 pi current I, and then I have cross product of ds. What is ds? ds has length ds, and the direction of dx is the same as the direction of current. So in this case, ds is to the right, ds cross r, where r is from the piece of wire to the point where we are looking for the magnetic field, ds cross r divided by r cubed. This is the law that we will be using to find the magnetic field created by this current. So to make our life easier, I will put letters here to indicate, to make difference between different segments. We will call this point A, we will call this point B, so this segment will be AB, this is C, and this is D. So we will start with segment AD. What is the magnetic field created by segment of this wire AD? So we have current that is flowing this way to the left. This is my ds in this formula. What is my r? R is from this segment to the point where we are looking for the magnetic field. So this is my r. ds is along r. It is in opposite direction, but they are entire parallel to each other. Then cross product ds cross r is 0. That was my r. ds cross r is 0, which means that the magnetic field created by this segment AD is 0. And I explain why. Because ds cross product ds cross r is 0. Unfortunately, yeah, you need to. ds cross r is equal to 0. Next one will be B. I use blue for this. Magnetic field created by segment BC. What is the magnetic field created by BC? Current is in this direction. This is my ds. What will be r? R is from ds to the point where we are looking for the magnetic field. This is my r for this case. ds is parallel to r, which means that the cross product ds cross r is again 0. and the magnetic field created by this segment BC is 0. Okay, now we move. Now what I will do, I will erase this R and I will erase this R. We already found the magnetic field created by these two segments, and next segment that I will be working with will be AB. So the magnetic field B created by segment AB, I need to write dB according to this formula. So this is my ds. The direction of current is the same as the direction of ds. This is length of infinitesimal length of wire. Now what is R? R is from the wire to the point where we are interested in the magnetic field. This is my R. R is in radial direction. ds is a piece of a circle. So R is perpendicular to ds. ds cross R is just product ds and R. I rewrite these constants, mu naught over 4 pi current I. Then ds is perpendicular to R. ds, so far I will leave it as ds. R is equal to B. I will write just magnitude. I will remove this vector sign. ds times B divided by R cubed divided by B cubed. And I have vector sign on the left, so I have to have vector sign on the right. What is the direction of the lines of the magnetic field created by this segment AB? So you use your right hand, I use my left hand to find cross product because you see my mirrored image. So what is ds cross R? This is ds. I turn my fingers towards R, and my thumb shows me the direction of the magnetic field at the point of interest. So the magnetic field is into the board created by AB. Magnetic field created by AB is into the board. Now we need to integrate this magnetic field, and I remind you that ds, what is length of arc? It is r times theta, then ds is r d theta. We know this. So what will be BAB? I need to integrate over this quarter of a circle. BAB, magnetic field created by length AB, will be mu naught over 4 pi I. All these are constants. B and B cubed will cancel each other. So I have here B squared, not each other, B squared. And then what? So can I add here? Let me rewrite it. I, and B is also constant. I take it out of integral. And now we have integral ds, which is radius B d theta. And I need to integrate from 0 to pi over 2. From 0 to pi over 2. B squared. I end up with B in denominator, which means that I have eventually mu naught I divided by 4 pi B. And integral d theta is just theta, so I have pi over 2. Pi and pi cancel out. We have mu naught I divided by 8b. We don't forget the direction. We have vector sign on the left. We have to have vector on the right. As we already found, the direction of the magnetic field created by this segment AB is into the page, according to our right-hand rule. You can also, instead of finding direction of cross product ds cross r, you can also put your thumb along current with your right hand, then grab the wire, and you see that at this point, if I grab the wire, here my fingers go out of page, and here they come into the page. So the direction of the magnetic field here is into the page. Of course, it is consistent to what we already found. That was the magnetic field created by AB. Now, the last part of this problem is to find the magnetic field. I will write it here. To find the magnetic field created by CD. CD. So I will start here because we understand that everything is the same, except I can actually start with, no, let's do it here. BCD. Everything is the same except for two things. We have different radius now. Radius is A, and we also have different direction of current. Now current is flowing this way. So how to find the direction of the magnetic field at this point? Well, we have ds. This is my ds. R is from ds to the point where I'm looking for the magnetic field. This is my R. What is ds cross R? You use your right hand to find the direction ds cross R, and we understand that since ds flipped the direction, then the direction of the magnetic field created by CD at this point now will be out of the page. So direction will be out, and the magnitude will be mu naught over 4 pi, current I, divided by A, the radius, and then integral from 0 to pi over 2 d theta will give me just pi over 2. Pi over 2 as in the previous problem. And finally, if I simplify it, mu naught I, pi and pi, divided by 8a out of page. Now, what will be the total magnetic field created by this wire with current I at the origin? B total. Now, I need to add these actually 4 magnetic fields as vectors. 2 of them are 0, so BAB, B total will be BAB plus BCD. I don't write other 2 because they are 0. And these 2 are in opposite directions. So either I put them as mu naught I over 8B in, and then I put mu naught I over 8A, and the direction is out. So, or when you start substituting the numbers here that you are given, you have to take into account that if one is positive, another one is negative. In this case, since A is less than B, we know what will be the direction of the magnetic field. So A is less than B, then this magnitude of this guy is greater than magnitude of that guy. So the net direction of the magnetic field after we add these 2 as vectors will be out. And my final expression will be mu naught I over 8, and then 1 over A minus 1 over B.